Good morning, everyone. Hello, am I audible? Hello, hello.
Good morning, ma'am.
Good morning. Happy New Year to everyone.
Happy New Year, ma'am.
Thank you. So, I think I have shared two assignments with you that has to be submitted by the end of this week. Yes? Please pick up. Hello, hello. Screen is visible to everyone.
Yes, ma'am.
Okay, so today we are going to start the next chapter, next unit, unit number 4, sequential ATPG. So, ATPG for sequential circuits. We have already covered the ATPG for combinational circuits, and I have also floated two assignments for you that has to be submitted. One has to be submitted by the end of this week, and next maybe by the next weekend. Okay, so I hope you have received the assignment and you are going to work on it. So sequential ATPs, what are the problems with sequential ATPs? So mainly what we are going to do, sequential ATPs means you have a combination circuit. This is your combination circuit, and you have a set of inputs, you have a set of outputs, and few of the outputs are faded back. So you have a set of flip-flops, right? And from here, few of the outputs are faded back to the input. So this we will call as sequential circuit. Yes or no? Right? So these are the primary inputs and these are the primary outputs and these are the partially fed back inputs, which are actually working as inputs and outputs as well. So here the problem is, in case of combinational circuits, we were just feeding forward. Whatever we are giving, that is only propagating towards output side from x to y. But here the thing is, partially you are having some of the inputs uh, which were the part of the output. So actually this is a cycle. So this is going to create a problem, how you will be preparing the input set so that you can detect it, because you don't know what was there at this end, right? Visible to everyone?
Yes, ma'am.
Since this is a feedback system, so you can fix this. Okay, this set of x is maybe 0, 0, 1, 0, whatever it is. But this set pi, you can't comment on this because this is coming from the output to again feedback. So this is the problem. So what approach we'll be using for this? So what will be the approach? We'll be converting the FSM, finite state machine, to corresponding iterative network. How we can do that? We'll break from here, right? And we'll make multiple copies of this combinational circuit, and we'll place all these circuits over here, and this will keep on repeating, right? So now we can justify, we can propagate. Okay, so if there was a single fault in sequential circuit, it means there are multiple set of faults in iterative circuit, right? So you may use different kinds of algorithm. Maybe whatever you have used for combinational circuits, the same set can be used, or the 9-value signal problem can also be used to propagate that fold, right? So first you have to make the multiple replicas of the original combinational circuit, and then you will be applying any algorithm. So what are the issues? The issues are the order of justification propagation. Since there are multiple replicas of the combinational circuit, so now the circuit becomes a little bit bigger, and you need multiple sequences of the inputs, right? So that is the problem. Another one is the simulation values. So simulation values will keep on changing because the input set is somewhere else, somewhat else at this stage. For next iterative network, the input set can be a little bit different because your main objective is the output set, which is actually becoming input for the next one. Another one is the test point insertion. This is the partial scan. You will be scanning that partially. So these are the issues seen by these sequential circuits. So what are the difficulties? First of all, main difficulty is initialization of bistable flip-flops because you don't know what was its value. So your first job is initialization of the values of the flip-flops so that there can be a fixed value at the input side of your iterative network. Gated clocks, circuits with multiple clock domains. You can have multiple clock domains, so it is going to create a problem. Internally derived clocks. You can also have internally derived clocks, mixed signal data, clock signals, asynchronous logic, circuits with combinational feedback paths, embedded counters, embedded RAMs, embedded ROMs. So these are the different kinds of issues. Because if you have embedded RAMs and embedded ROMs, that is also called as sequential circuits. So if the complexity is going to increase, it might be creating difficulties for you. So this is the example we are going to take. Okay. We are going to take a simple serial adder. This is 1-bit full adder. This is sum for 1-bit full adder. AI XOR BI XOR CI minus 1. Okay. This is the logic for sum. For the carry, what is the logic? Whenever any 2 bits are 1 1, then your output of carry is 1. Okay, so AI BI plus CI minus 1 AI plus CI minus 1 BI. So, and you can convert it into this way also, AI plus BI into Ci minus 1. So if you are going to convert it into a logical block diagram, it will look like this. AI, BI are actually inputs, and Ci is actually from the feedback system. So first of all, you will be preparing AI, BI, end of it, AI or BI, then ended with Ci minus 1, and then ORing of this AI, BI, and this is going to a flip flop, and from flip flop it is going to the feedback path here, and the sum is just XOR of this. Okay, so XOR of all these three is XOR gate. So here this whole logic is for Ci calculation, Ci minus 1 calculation, and the clock is there in the flip flop which is storing the value of the clock. Understood?
एक लड़की भीगी बारिश से सोती रातों में बारिश से
Sumit Prajapati. Sumit Prajapati.
किसका बर्थडे आज यहाँ पे क्यों बैठे किसका गिफ्ट नंबर दे मुझे किसका बर्थडे नंबर की जाके रहना यहाँ यहाँ क्यों बैठे तुम भी लोग
We have singers also in the group. Sorry to disturb. Okay. Shall we start? Shall we restart? Hello? Yeah.
Yes, ma'am.
What we are going to do, we are preparing this network. Now, you can see this is a sequential circuit, right? And in this sequential circuit, there is a feedback issue also. You are getting feedback in terms of Ci minus 1. The output of this is going back to the input of this. Okay, this is going to this also, and this is going towards this also. Fine. So in this fashion, if there is, let's say there is any fault over here, it is really very difficult to propagate with one set of this network. So what you will be doing is you will be breaking it. Okay, and you will make the multiple ripple cause of this circuit. So how you will be doing that? Let's understand. So this is how you will be doing it. Just break the circuit before the flip flop. Here was the flip flop. So you have broken the circuit, and now this is working. This Ci minus 1 is working as the input for the next iterative network. This is one set of iterative network. This is another set of iterative network. And this Ci minus 1 is the input, third input for the next iterative network. Likewise, here also this is Ci is the input for the next iterative network, and these are known as the time frames: time frame 0, time frame 1, time frame 2. Time frame, why? Because there is clock, right? So at first clock this will be active, next clock cycle this is valid, for the third clock cycle this is valid. So we have given the name time frame according to the clock values. Okay, so the time frame is decided by the one clock period, because we are thinking that in one clock period this whole circuit is invoked. That's it. Okay, समझ में आया?
Yes, ma'am.
Okay, so now let's proceed. So this is the general model of the sequential circuit. Here you have a set of inputs x, which is a vector. You have set of outputs z, which is again maybe multiple outputs. Some of the outputs you have taken for the feedback, so these outputs will go to the set of flip-flops. For every one uh, partial faded back input, you need one flip-flop. So if let's say these are n number, so n number of flip-flops are needed, okay, to retain these values. And then this is faded back, so this is again a vector y. So this is how the sequential circuit model is represented. We call this as Huffman model, and this is the generalized case. You have to remove the set of flip-flops because that you are converting into time frame. So you'll say time frame 0, time frame 1, time frame r, like that. Okay, so here you will be having y1. This y1 is now working as input for the next frame, right? And then you will be having y2 output of this, that will be working as the input for the next, and it will keep going on, right? So this is how we'll be doing. So your first job is you have to remove the D flip-flop set. You have to cut down the circuit from there, give some name, yi, xi, ci or something, that will be working as the input for the next iterative network and keep going on. Okay, so this is how you will be creating. But now the interesting point is, since this was what, this was the partial feedback input set, right? Y0, yes or no?
Yes, ma'am.
Right. So now, when you are going to propagate the fault, this x0 you can fix, but this y0 you can't fix, right? because this was the partial feedback system. This was from the partial feedback system, right? So first of all, your objective is not the fault propagation, but to get certain values at y1. Yes or no? You
Yes,
will
ma'am.
fix the set of x0 in such a way that your y0 is don't care, right? And you will be having certain values of x0 in such a way that you are getting some definite value, either 0, 1, or whatever fixed value for y1. Once you have fixed these values, you will try to make x1 in such a way that you can get the wanted value at y2. That will be your objective. And once this set is okay, you have these y2 values according to you. You will be putting x2 in such a fashion that this combination of y2 and x2 is able to propagate the fault at the output. And output is what? These are the outputs. These are the visible outputs. Y's are not the visible outputs, right? So your job is to propagate that effect onto ZIs. So of course, Z2 onwards, this effect can be propagated. So this is your job, right? So you understood the complexity. There is a single fault, but the single fault requires these many values. First of all, to bring y1 at a certain level. Second, y2 at a particular value. This is your target, to bring y2 at a particular value, y2 set. And now your objective is to propagate that fault through y2 and x2 combination to z2. So you can think you need three sequences at least, right? It may be two sequences also. If y1 in first go you are having the desired value of y1, then it can be at least two sequences also. So let us understand how it is going to work. So this is the general case. I'm just escaping it. So this is the example. Okay. Sumit is back. Okay. Yeah. So this is the example. किसका example है ये? One bit full adder, right? One bit full adder. What we did, we have converted that into iterative network by breaking from here. Here there was a flip-flop, so and there was a feedback. So we removed the feedback and we have made it feed forward network. From here we have removed it and we made it feed forward network, right? So in this feed forward network, this is one iterative network. Likewise, this is another iterative network. This is third iterative network. Now, what is our primary goal? Primary objective क्या है? क्या बताया था सबसे पहले? This is your C0. So first of all, because C in, we don't know what it was, because this was from the feedback system. So what is your objective? Your objective is to bring C0 to some certain value. And here, test for P stuck at 0. And P is actually this. P आपका यहाँ है. इसको stuck at 0 करना है. If you want to make it stuck at 0, so what is your objective? This is stuck at 0. So your objective is to bring it to 1. So this is what you need to bring it to 1. इसको आपको 1 लेकर आना है, right? And if this is 1 and you have to propagate this fault from this to this and then this to this, यही बात है ना? Yes.
Yes, ma'am.
Okay. So if you want to propagate it in this fashion, यहाँ से आपका path है. This is C0. C0 has to have certain value, then it will go here and then. So you have to tell me that what will be value of C0. C0 का target क्या होना चाहिए हमारा?
One.
Non-controlling value of end, that is 1, right? So C0 1 is our target. ये बात समझ में आई कि नहीं आई सभी को? Yes. This is 1 And what will be the target for this?
0.
0. Non-controlling value for OR gate is 0. So I need 0 here, and I need 1 at this, so that I can have the faulty value. Whatever faulty value was there at P1, the same value can be propagate, and then this will be giving you the C1 faulty value, and from here I can have the I can push that at the output. Okay, so this is the set. So let us start it. So first target is C0 is equal to 1, right? And C0 is here. C0 is equal to 1 is my first target. So C0 is equal to 1. For this, what I need to do? I don't know what is my C in, right? C in अगर मुझे नहीं पता है, so how I will make C0 1? So C0 का हमारा what was the C0?
मैम
हाँ बोलो.
मैम वाई C0 is equals to 1.
दिस इज अवर गोल. अभी बताया ना आपको C0 1 होगा तभी तो फॉल्ट इज हियर, राइट?
तो मैम फॉल्ट तो इसी लाइन से प्रोपोगेट करना चाह रहे हैं ना हम, तो फिर इसी पे वैल्यू क्यों फिक्स करेंगे, इससे तो फॉल्ट प्रोपोगेट होगी.
कौन बोल रहा है?
यस मैम.
अर्पण. कौन बोल रहा है?
यस
यक्षराज. ओके, fine. So what is our objective? I told you CIs are unknown to us because this was a feedback path, feedback signal, right? यही था ना?
यस मैम.
तो अगर ये फीडबैक था, व्हाट इज माय प्राइमरी ऑब्जेक्टिव? माय प्राइमरी ऑब्जेक्टिव इज टू bring it to a certain value, right? So if you want to bring it to a certain value, that is your primary objective, because C in was from the feedback. ये यहाँ पर फ्लिप फ्लॉप था, फिर ये फीडबैक था. So feedback वाला, how I could know that what was the initial value of the flip flop? That I don't know. So initially my scene was X, right? X Raj, fine.
Ma'am, but okay, so ma'am, you said that C0 we take as 1 because it is non-controlling value. What was the reason for that?
Okay, I'm coming to that point, but first please understand. First, my target is C0 to a fixed value because scene was X. It was a don't care condition because of the feedback system, right? Correct?
Yes, ma'am.
Okay. Now fault is where? Fault is residing at P. Okay. Fault कहाँ पर है आपका? Fault आपका यहाँ है. But यहाँ पर C तो आपका X था. If this is X, so what will be? Whatever the fault is at P0, इसका कुछ फर्क नहीं पड़ने वाला. सो इसका मतलब आपका जो भी आउटपुट आएगा that is not known to you. So first you have to fix to C0. C0 को फिक्स करना पड़ेगा. And what value you should fix so that this fault can be propagated at the output? So इसका non controlling value is 1. So you have to take C0 is equal to 1 so that the fault stuck at 0 at this line can be propagated at the output, right? And from here it has to be propagated to this line so that from here it can go to the output, because this is my primary output. This was the partial output which I cannot see, I cannot check, and since it is coming through this, so this has to be 0 here because the non-controlling value for OR gate is 0. Yakshraj, would you understand now? Hello, am I audible?
Yes, ma'am.
Priyanshu, can you understand it? Yeah.
Yes,
Shall we
ma'am.
proceed? Okay. Okay. So our target was C0 is equal to 1. When I can have C0 is equal to 1 if CD not known to you. C0 1 कब होगा? जब सीड आपको known नहीं है whether it is 0 or 1. So we know the carry can be generated when AI and BI is 1 1, right? जब आपका ए आई बी आई 1 है, इफ यू रिमेम्बर, आपका सी जो कैरी था उसमें आ रहा था ए आई बी आई प्लस सी आई माइनस 1. So if this is don't care, let's say it was 0 or 1, we don't care. So if this becomes 1, it means we will just ignore whatever the ci minus 1 term is. Okay, so if I'm making both of these 1 1, so a0 and b0, so it means my c0 will become 1. Yes or no? So this is my A0, B0. If I'm making this 1, 1, I'm getting 1 here. So if this was X, I don't care whatever it was. So यहाँ पर जो भी कुछ हो, I don't care. I will be getting at the output 1. Yes? So the first sequence is A0, B0 is equal to 1. A0 is equal to 1, B0 is equal to 1. This is my first sequence. Okay? Yeah? Now, what is the next target? So, next target is to propagate this fold. This is stuck at 0. ये क्या है आपका stuck at 0 है. आपको इसको क्या बनाना है? 1 बनाना है, right? If this is stuck at 0, your job is to bring 1 here. यहाँ पर 1 कब आएगा? So, look it here. AI, BI. Both of these are here. And the OR of these is actually PI. Okay, C0 we have fixed to 1, so no problem, it is going 1 from this. But here we need, along with this, we need 0. So actually one of these is expected to be 1 and another can be 0. So let's make this is 1 and this is 0. So this is making my goal 0 here, and here 1 plus 0 is become 1 here, right? So stuck at 0 is activating with when I am going to push 1 over here. This 1 1 is actually the faulty. I am getting, see, actual it was stuck at 0, so actual was 1 and faulty is 0. So I can say D. So D is getting propagated through this, and since this was 0, so D I am getting here. समझ में आया?
Yes, ma'am.
ओके, अभी जो ये प्रोपोगेट हो चुका है यहाँ पर, you have propagated it to this line, but still it is not at the output line. आपको कहाँ ले जाना है इसको? Here you need to bring it at the primary output. Okay, नहीं है भैया? Your job is to bring it here. Your job is to bring it here. Okay, so now you have to set the values of A2 and B2 so that whatever you had over here, that can be propagated at the output. So you can see C1 is equal to D XOR with A2 XOR with B2. So D को किसके साथ XOR करें so that you can get the value either D or D dash. So अगर 0 के साथ 0 को 0 के साथ XOR करेंगे क्या आएगा?
0.
0. 0 को किसी के साथ XOR करेंगे, you will get the same value. D another complement of that plus D bar 0. So you are getting D at the output if you are having A2 B2 0. So D is at the output. So the fault has been propagated at the primary output S2. आ गया समझ में?
Ma'am,
Yes.
हाँ बोलो.
ma'am, we can also have A2 and B2 as 1, no?
A2 and B2 as 1 1. Yeah, that will also work. Yes. That is also going to work. दोनों 1 1 होंगे, then also XOR of this is going to be 0, right? And D is going to be propagated at the output. Okay?
Okay.
Ma'am, A2 and B2 can also be 1 0 because then we will get D bar at the output instead of D.
हाँ. Yes, that is also correct. 0 1 is also correct. So in this fashion you are going to propagate. So these are different sets. you will be having, and this sequence has to be maintained, right? So for example, the first one, to bring 1 1, there was only one condition, and the one condition was a0 b0 1 1. That was the one condition. So the first sequence is 1 1. C in we don't know, so don't care. Now C in becomes 1 for the next cycle, and this set is actually either 1 0 और 0 1. दोनों काम करेंगे कि नहीं करेंगे?
Yes, ma'am, both will work.
Okay. Third वाले में you are having D here, and this has to be propagated at the output, so you can have whatever D was here and here XX. Yes, don't care. A2 B2 कुछ भी हो, this will go to the output. Yes or no?
Yes, ma'am.
सही है ना? So in this fashion, you can propagate the fault in the sequential circuits. ठीक है, अगर किसी को अभी तक का समझ में नहीं आया, प्लीज आस्क, आई विल रिपीट इट. सभी को समझ में आ गया? मनीषा, यू
Yes,
अंडरस्टूड? समझ में आ गया?
yes, ma'am.
बताओ तो, व्हाट इज अवर प्राइमरी ऑब्जेक्टिव? सिक्वेंशियल सर्किट्स में प्राइमरी ऑब्जेक्टिव क्या होना चाहिए? Abhinav, can you tell me what should be our primary objective in sequential circuits?
Yes, ma'am. Basically, the primary objective is to propagate the folds. So, corresponding to that, we first of all take all non-controlling values, and after that, we have to pass the another value of fault. Suppose the fault is 1, so we have to pass 0. So, corresponding to that, we take the rest inputs.
So, Naman Kumar, what is the primary goal, Naman? Sukriti Vora.
Ma'am, in case of sequential circuit, we have to find the value of the feedback input.
Correct. This is the primary objective because feedback input हमारा x पर है. उसको हमें पहले justify करना है to a certain value. जो भी हमारा ऑब्जेक्टिव रहेगा, वो सारे इनपुट्स को यूज करते हुए वी विल बी अचीविंग. तो अभी हमारा जो फीडबैक सिस्टम वाला है वो तो एक्स है. सो अभिनव, द प्राइमरी ऑब्जेक्टिव इन द सिक्वेंशियल सर्किट्स इज टू फाइंड द अननोन वैल्यूज. इनपुट्स आपको प्राइमरी इनपुट्स ऐसे सेलेक्ट करने हैं सो दैट द फीडबैक set of inputs is to can have a fixed value, right? That is our primary objective, and then we will proceed forward. Okay.
मैम,
हाँ बोलो.
जो लास्ट स्टेप में फिर वो सीन जो हमने इनिशियली डोंट केयर लिया था, उसका लास्ट में क्या हुआ था?
सी इन जो डोंट केयर था, दैट इज व्हाट C1 C2 सी इन की तो वैल्यूज है, वो क्या है? इनिशियली इट वाज डोंट केयर, बट when we applied A0 and B0 1 1, so C1 was set to 1, right? So C1 is what? C1 C in का ही 1 iteration के बाद सिग्नल है, right? Scene was 1 because we don't know what was there in what was the initial value of the flip flop state. तो इसीलिए सीन को या किसी भी फेडेड बैक इनपुट्स को हम एक्स लेंगे इनिशियली.
तो जब सीजन आया था तो फॉल्ट डी प्रोपोगेट हो गई, तो फिर हम वहां रुक जाएंगे.
हाँ, डी अगर आपका प्रोपोगेट हो चुका है, डी और डी डैश एट द आउटपुट, वी विल स्टॉप देयर. और जितने भी तब तक सीक्वेंस लिए उन सबको हम एनलिस्ट करेंगे और हम बोलेंगे दिस इज द टेस्ट वेक्टर फॉर दिस टेस्ट, propagating this test to the output. This is the test vector. For example, in this case, हमारे पास you are having 3 set of input vectors. लेकिन 3 sets में आपके पास देखिए कितने आ गए. You are having one set, and one set. This is one. Okay. you are having one set, another set and one out of this. ठीक है, so 4 बार इसका 4 बार इसका, you have total 8 set of sequences to propagate this fold. समझ में आ गया? You will keep on multiplying, right?
तो मैम जो इसी वैल्यू की वैल्यू थी वो भी टेस्ट वेक्टर अवेलेबल गिवन की
Your
थी।
voice is not clear to me. Your voice is not clear. Please revise.
मैम देन जब A0 B0 की जो वैल्यूज है वो भी हमारा टेस्ट वेक्टर है, A1 B1 वो भी टेस्ट वेक्टर है।
हाँ, ये सीक्वेंस में टेस्ट वेक्टर जो है ना, दैट इज in the sequence you have to mention the sequence, okay, at time frame 0 this, 1 this and 2 this, तब ये टेस्ट वेक्टर बनेगा. दिस इज नॉट ए सिंगल सेट, दिस इज ए सीक्वेंस ऑफ इनपुट टेस्ट वेक्टर्स. ठीक है, और वो सारे आपको आंसर पे मेंशन करने हैं. ओके, फॉर एग्जांपल इसका मैं आपको एक मेंशन करके बता देती हूँ व्हाट इज द टेस्ट वेक्टर. हाँ, एक मिनट, वन बाय वन. मुझे थोड़ा सुनाई कम दे रहा है आज, तो आप थोड़ा स्पष्ट बोलने की कोशिश करें. सो द टेस्ट वेक्टर फॉर दिस इज ABC, इन लिख रही हूँ मैं, आप ऐसे लिख सकते हैं ABC. सो दिस, then 0 1 1 and then let's say 0 0 D. Okay, so mainly AB is in your control, so AB का ही सीक्वेंस आप लिखेंगे, C को तो लिखने की जरूरत नहीं है. Okay, so you can just write 1 1 0 1 0 0 is your test vector. ठीक है, क्या आ गया समझ में?
यस मैम।
Okay, shall we proceed?
मैम एक बार और बता दो क्या पूरा प्रोसेस एक लाइन में, बस थोड़ा डिस्कनेक्ट हो रहा है मेरा नेटवर्क बार बार.
कोई बात नहीं, मैं दोबारा बता देती हूँ. एक बार ध्यान से सुनना सभी लोग. हमें क्या करना है सबसे पहले, बिकॉज वी डोंट नो व्हाट वाज द फीडबैक सेट ऑफ इनपुट्स. तो सबसे पहले आपका प्राइमरी ऑब्जेक्टिव है फीडबैक सेट ऑफ इनपुट्स को सेट करना. यहाँ पर फीडबैक क्या था? C0 को सेट करना, इधर 0 to 1, 0 और 1. अब हमारा जो फॉल्ट है वो यहाँ पर है. यहाँ पर फॉल्ट प्रोपोगेट करने के लिए व्हाट C0 इज नीडेड, 1 चाहिए हमें. ठीक है, सो प्राइमरी ऑब्जेक्टिव आपको A0 B0 इस तरह से चूज करना है कि आपका C0 इज 1, A0 B0 इफ इट इज 1 1 देन C0 बिकम्स 1, राइट. जब ये 1 हो गया, दिस दिस 1 एंड दिस फॉल्टी लाइन विल बी प्रोपोगेटिंग द फॉल्ट थ्रू दिस टू दिस टू दिस टू दिस. तो इसके लिए हमें बाकी चीजों को unaffected करना पड़ेगा. So non-controlling value for OR gate is 0. So your objective is to make it 0. So if I'm making 0 1, so this is going to become 0, and the objective of this is to bring it 1, because the stuck at 0 fault था आपका P पर ना. So if you are making it 0 1, so it means यहाँ पर आपके पास 1 आ जाएगा because ORing है. और यहाँ पर नॉन कंट्रोलिंग वैल्यू C0 1 था. सो दिस फॉल्ट D कैन बी प्रोपोगेटेड हियर. यहाँ पर आपका प्रोपोगेट हो जाएगा. A2 B2 आपको चूज करना है. A2 B2 अगर आपने 1 1 चूज किया, सो इट इज गोइंग टू गिव यू D XOR 1 XOR 1. सो व्हाट विल बी द सम विल बी D. कोई भी सेट ले लोगी A2 B2 का, द D इज गोइंग टू प्रोपोगेट द आउटपुट, राइट, इन फॉर्म ऑफ D और D डैश. And this was your objective, that's it. Yeah, आ गया समझ में?
Yes ma'am.
Okay, shall we proceed now?
Yes ma'am.
Okay, अभी this is another example. ये एक दूसरा एग्जाम्पल है. Here U is stuck at 1. You can see U आपका यहाँ पर है एंड दिस इज स्टक एट 1 वोल्ट। यहाँ पर ये स्टक एट 1 वोल्ट है, ठीक है। यहाँ पर ये देखिए फीडबैक इज गोइंग फ्रॉम दिस टू दिस साइड, इधर आपका फीडबैक जा रहा है, ठीक है। तो आप इस सर्किट को ड्रॉ कर लीजिए, just draw this circuit. U, V, W are three inputs, and then there are gates, OR gate, NOR gate, and all these. So just draw this circuit. इसको हम कल डिस्कस करेंगे क्योंकि अभी 15 मिनट बचे हैं, 15 मिनट में नहीं हो पाएगा, ठीक है। तो मैं आपकी हेल्प कर देती हूँ। यू जस्ट ड्रॉ दिस सर्किट एंड ट्राई इट होम, then tomorrow at 9 a.m. we will be discussing it and we will figuring out what exactly the output should be. So सबसे पहले हमें क्या करना है, once you have to draw the circuit in one frame, then you will make the multiple ripple cause of the frame. So this why you will make a cut over here, यहाँ पर आप कट बनाएंगे, ठीक है। So ये जो आपका आउटपुट है, ये आपका यहाँ पर इनपुट बन जाएगा y0 and this is actually your y1, right? ये आपका क्या बन जाएगा y1, this is your y1. Now you will be getting the next frame. So ये आपका आउटपुट ही रहेगा, this is not a feedback, so z is output here. So z0, z1 and all these will be the set of outputs and these will be the inputs, these will be the input set, okay. So what should be your primary objective? Your primary objective is to bring y1 to a certain value, right? आपको y1 को एक certain value पर लेकर आना है, दिस इज योर प्राइमरी ऑब्जेक्टिव। अब y1 को एक सर्टेन वैल्यू पर क्यों लेकर आना है, द रीजन बीइंग, ये देखिए ये जो y1 है दिस इज गोइंग टू अफेक्ट द आउटपुट। ये देखिए यहाँ से आया, इट इज गोइंग थ्रू दिस टू दिस टू दिस, right? There is a single output and that is getting affected with y, so that's why you need to bring it to a certain value, okay, right? अभी देखिए आगे क्या करना है आपको। Once you have drawn this network, you have to check how you will be, once you have uh, found a certain value of y1, you have to check how you will be propagating the fault. So there are three ways to propagate the fault. First one is this, you'll be going through this to this to this to this. Another way is from here to here to here, like this. Third way is from this to this to this. So there are three paths to propagate your fault. So if this becomes a multiple path problem, right? So you will take a decision that which path you should choose to propagate your fault at input U, and then you will be selecting V and W to support your decision. Got it? Huh?
Yes, ma'am.
Okay. So in this fashion, finally you will be able, after some iterations, you will be able to figure out, okay, this should be the sequence of inputs so that you can find the correct fault propagated at the Z output. Okay? ठीक है, डायग्राम बना लिया सभी ने?
Ma'am,
हाँ बोलो।
Yes,
ma'am,
ma'am.
there's a confusion based on the assignment we need to submit.
हाँ हाँ बोलो।
Ma'am, one of them is I think you have posted a material to make notes of Unit 3. So is that the first assignment?
नहीं नहीं, मैंने कुछ क्वेश्चन शेयर किए थे, वही फर्स्ट असाइनमेंट है। कुछ क्वेश्चंस होंगे 4 या 5, वो है फर्स्ट असाइनमेंट।
किस प्लेटफॉर्म पे, क्लासरूम या फिर मेल?
एक बार मैं चेक करके बताती हूँ। आई प्रिपेयर्ड सम क्वेश्चंस और उनको फिर मैंने पोस्ट किया था। वो मेकिंग द नोट्स वो तो आपके खुद के लिए है, सो दैट यू कैन अंडरस्टैंड दैट बेटर, ठीक है।
But
Ma'am, you
questions
haven't
शायद
posted any questions.
नहीं पोस्ट किया है, चलो मैं आज कर दूंगी। फिर मैंने प्रिपेयर तो किए थे, आई रिमेम्बर। मैं पोस्ट कर दूंगी, आज कर दूंगी अगर नहीं किए तो, ठीक है।
ओके मैम, थैंक यू।
सो वो अभी तक जो पढ़ाया गया था 3rd यूनिट तक, उनमें से है वो क्वेश्चंस, ठीक है। 4 to 5 क्वेश्चंस वी हैव एंड इसका आपको आई थिंक आई प्रिपेयर्ड इट। आपको इसके नोट्स बनाने हैं एंड यू विल बी आस्क्ड टू प्रेजेंट दिस जो टॉपिक इसमें रह गए हैं यूनिट नंबर 3 में, यूनिट नंबर 4, यूनिट नंबर 5 में इटैलिक्स में लिखे हुए हैं। उन टॉपिक्स को आपको याद करना है, नोट्स बनाने हैं एंड रेंडमली आई विल बी आस्किंग एनी वन टॉपिक टू प्रेजेंट फॉर 5 मिनट्स। ऑनलाइन होगा ये प्रेजेंटेशन। सो वो आपका 5 मार्क्स का रहेगा। ठीक है, 5 नंबर का एक असाइनमेंट, 5 का दूसरा असाइनमेंट रहेगा। टोटल 20 मार्क्स हो जाएंगे।
कब तक
ठीक है,
करना है?
प्रेजेंटेशन वाला तो जो इटैलिक्स में है उसको तो आप अभी से शुरू कर दीजिए, सो दैट मे बी इन द 3rd week of Jan I can take the presentation in online mode and I can submit the marks. और ये आप बता रहे हैं कि आपको नहीं मिला है, सो आई विल बी पोस्टिंग दिस टुडे। आज असाइनमेंट पोस्ट कर दूंगी और एक असाइनमेंट और रहेगा 5 नंबर का, 5-6 क्वेश्चंस, वो बाद में पोस्ट कर दूंगी। फिर 5 क्वेश्चन है, आप 2 घंटे में आराम से कर पाएंगे। छोटे ही है, न्यूमेरिकल्स हैं, दैट्स इट। ठीक है, या एनी अदर क्वेश्चन? हेलो, डू यू हैव एनी अदर क्वेश्चन सो फार?
No,
या
ma'am.
अटेंडेंस ले लूं? ठीक है, ओके। तो अभी जो बताया है इसको अगले क्लास में जब आप आएंगे सो ट्राई करके आना इसको, ठीक है, so that we can discuss how it is going, you can understand it in a better way. चलो ठीक है, अभी मैं स्टॉप करती हूँ। आई हैव टेकन द अटेंडेंस एज वेल। थैंक यू, सी यू टुमारो, बाय, हैप्पी न्यू ईयर वंस अगेन।